All right, so my apologies. I screwed up last week and I did a video for section 7.7, but I posted homework for section 7.6 and I never made a video for section 7.6. So I'm sorry for that. I'm going to go over section 7.6 now. And you can then do the homework. I'll post it again. I posted it last week, but that was in the wrong place. So I'll post it again. I asked for your input on when to have a test. However, only a very few people responded. So being left up to me, we're going to do it on Thursday. All right. So we're going to do a test on Thursday on this because we only have to do section 7.6 right now. It's not that tough. And then that will give us Wednesday to review and then Thursday for the test. And then I think I'll probably give you a break on Friday and just let you have a day off there, okay? So section 7.6 deals with arc length and sector angle. So if you have a circle, so think of it like a piece of, like a pie or a pizza or something, and you have a section in it here, okay? So you have like a piece of pie or a piece of pizza. The angle that goes from one radius to the other radius, right? Because this is a radius because it goes from the center out to the edge. This is a radius because it goes from the center out to the edge. This right here, that little symbol is just a circle with a wavy line through it. That's called a theta. It's a Greek letter. It's usually used to represent angles in math. That is the sector angle. And the distance from where one radius is to where the other radius is, along that curved edge, that is called the arc length. And then the area of this piece of pie or piece of pizza, whatever it is, that is the sector area. All right? So that's all the pieces. So we're going to talk about two formulas in here, if I remember right. Yeah, we're going to talk about two formulas in here. We're going to talk about a formula for arc length. We're going to talk about a formula for arc length. And so for arc length, the formula is m over 360, and I'll talk about what that m is in a minute, times 2 pi r. All right, so they don't actually use that Greek letter theta. They actually use the m to be the sector angle. So m is the sector angle. When I teach it in, I think it's in calculus, they put a theta there, not an m. So in my head, that's what it is. So if you want to know the arc length, the distance of this curved piece right here, it would be the sector angle over 360 times 2 pi r. Now 2 pi r, because that's the length around the full circle. You just want to know a piece of it. So that's why they put this ratio here of the sector angle over 360, because the full circle is 360. Now, what if you want to know the sector area? So sector area. There's a formula for that as well. It's very similar. It's just m over 360, but because this time it's area, rather than do the circumference, the length around the outside, we do what would be the full area of the circle, which is pi r squared. A lot of people mess these two formulas up. They mix them up, but there's no need to, because length goes with the distance around the outside of the circle. Length, 2 pi r. Sector area goes with the formula that has the area of a circle, pi r squared. So they go together. So there's no need to screw it up, and it's always with this angle. So we're going to do one example, and that's it. There's just one example we're doing for this, so it won't take very long. So in example 1, on page 434, and I'm getting it right this time, they give us a circle. Oh, that was awful. And they say the sector angle is 100 degrees and the radius is 25 meters. This is a water sprinkler, and it's one of those, so someone has set a water sprinkler on their lawn, and it's one of those ones that pops up and kind of goes in part of a circle. My dogs love to walk by them and get wet sometimes when we used to walk in town. So the sprinkler throws water out there, comes around, goes to here, and then comes back, and then water. So only a portion of the lawn is getting watered. So their question is, what is the length of the arc of the watered sector? So we are looking for the length of the arc. We're looking for the arc length. So arc length is m, which is the sector angle, over 360 times 2 times pi times r, which is 25. Okay? And then that's just a matter of putting that in your calculator. Please use your pi button on your calculator, not just 3.14. 3.14 will throw your answer off slightly. They said to the nearest meter, so no decimals. So when they put it in their calculator, they got 44 meters. So it's throwing water 44 meters along this arc. Okay? The second part of the question is, what area of their lawn is actually getting watered? So that is area. So very similar formula, still 100 over 360, but this time times pi r squared, and my r is 25. They tell us in this one to round it off to the nearest square meter, so again, no decimals involved. So I would just do 100 over 360 times pi times 25 squared, rounds off to 545 meters squared. So that's it. It's just a matter of using that formula. That's all there is to it. So I will post the questions again. I already posted them last week, and then I posted the correction, but I will post those. All right. So we will have a test on Thursday. Test on Thursday. I'll review tomorrow. I'll talk through a few. Maybe I'll do a few off of the review at the end of the chapter, and I'll talk a little bit about what to expect on the test. All right? Talk to you again tomorrow, I guess.